To continue chapter 11, now finding a z-score given a probability. So we're going to use the table backwards. Previously, we figure out the z-score. We take our score. We use the formula. We figure out the z-score. Then we go to the table to look up what percent, right? The probability. What if we want the other way around? Say we have the probability but want the z-score. So, for example, find a standard normal distribution and given that z is greater than some kind of number, or what's the z-score? So, well, first of all, we know it's greater than, again, we have to do 1 minus. So we do 1 minus 0.9247, we get the number we want, 0.0753. Then you find the closest value on the table, which is the closest you can find close to 0.0753, is 0.0749. And if you look outwards, you will see that those z-scores, corresponding z-score is negative 1.44. That's the answer. Okay. So, once again, okay. Now, these are just a couple more examples, okay, but we want to find the x value instead. So we have the same question, okay, where we want to find a z-score that's greater than something. We don't know what that is, but we know the area is 0.7983. So since it's greater than, the first thing we're going to do is 1 minus, and then we go to the table, find this value. We use the table just like the way it is. We instead of look up the z value, look up the probability, we go from inside out. So you look up the closest value to 0.2017. Look outwards, you will find the z value, negative 0.84. Now here's the formula for how to find x. Okay, that means what's the cutoff value will give me that probability. So x equal to the mean plus the z, which you find, and the standard deviation. Then you get 8.488. All right, we'll say, well, what is that for? Okay, so I'm going to think about this for a minute. We'll come back to it. We're going to give an example for that. Okay, in a real life example, make more sense. So here it is. Suppose that the wrapper of a certain candy bar, unless its weight is at 2.13 ounces. Naturally, the weight of individual bar varies somewhat. Suppose the weight of the candy bar vary according to normal distribution, with the mean is 2.2 ounces and the standard deviation, it varies a little bit, 0.04 ounce. What proportion of the candy weigh less than the advertised weight? Okay, this is something we've done before. So what's the probability you'll be less than 2.13, right? So then we take 2.13 minus the mean divided by standard deviation, negative 1.75. And since it's less than, we just look up negative 1.75 in the table. We get about 4%. Okay. All right. So here again, it's the same question. What if we have in between? Okay. So what are the chances you find a candy bar that's between 2.2 and 2.3? So we do 2.2. We change that to z. Then we take the 2.3, we do the same thing, we change it to z. Then once we have that, we want to find z's between 0 to 2.5. Look up 2.5, that's the table value. Look up 0, that's the table value. We subtract, we got the proportion that we want. It's a percent. Okay. So, and this is again using empirical rule. Okay, so you can use empirical rule if you, especially when the question asks you about 99.7, they look familiar. So they tell you that you have they're making widgets, right? So the most important thing, you look for the mean and the standard deviation. Mean is in the middle, 51. Standard deviation is 4. So we add 4 once, twice, 3 times, and we minus 4 once, twice, 3 times. Then remember, empirical rule says 68 in the middle, 95, and 99.7. So between 39 to 63 is 99.7. They ask you what are the weights, right? Okay. Right, and then same thing between 43 to 63. Right here it is. Okay. Now, now the question is, well, how do we get 43 to 63, right? Okay, so what we can do, we can divide this out. You say, okay, so if from 43 to 63, the only thing missing is this a little bit, right? So there's other tables, normal table you can I don't know, we have one in the textbook too, where they don't just have 68, 95, 90.7. They just divide into all little pieces. So for example, if this is 68, so this from 47 to 55, 68. But if you divide it by half, then it'll be 34, 34 each. So if you do the same logic, there are different values for each piece. So if you look that up, which is okay, then you can easily calculate how much, then just add up all the areas on the different panels. And again, your textbook have the detailed one that cut up the 68, 95, 99.7. Okay, same thing for this one. Now, but what I want to do is another question that you need to use this, okay, is when do you ever use this formula? Is when you have a question like, say you have a test. The test was the average was 70, standard deviation is 5. Okay, so here's average, here's a standard deviation. Now, what if I want to say what do you need to score on this test to get an A? Now, so you're saying, okay, what's the probability of X greater than 90, right? 90% is what you want. So, well, 90% means top 10%, right? So what you want to do is just imagine this question saying, well, what value will give me 90%, right? You want to be top 10% means you beat 90% of the people in the class, right? Because remember, Z table is what's to the left of you. So the Z table is the area to the left. So if you're top 10%, that means the area to the left of you is 90%. So in that case, or since you want a 10%, your top 10% you do, so it's same thing. You do 1 minus 10%, then you get 90%. So when you look up 90%, you get a Z value. Then you plug in a Z value here, and with the mean and standard deviation provided for you. If that's the case, then you will get the number, the cutoff number, to make your data the top 10%, and that will be the number getting an A. All right, so for more examples, feel free to email me, okay, and I'll be more than happy to walk you through it.